Tēnā koutou katoa. Welcome back to a brand new math video. Today we are going to prove that the limit as x tends to 0 of sine of x multiplied by cos x all divided by x is equal to 0. And yes, the cos x and the x is within the sine. And you might go, well, this could be fairly difficult, but I'm going to show to you, in fact, it is not. So let's go ahead and let's start by plugging in x is equal to 0. Step 1, plug in x is equal to 0, see if we get indeterminate form. So we get sine of 0 multiplied by the cos of 0, all divided by 0, and that is going to be sine of 0 multiplied by 1, which is 0, all divided by 0, and we know that sine of 0 is 0, so we get 0 over 0. And that's a form of indeterminates, and that means that we can apply L'Hopital's rule. And L'Hopital's rule actually states that if we have the limit as x tends to 0 or some arbitrary constant of g of x over p of x such that that is going to be equal to 0 over 0, then the limit, then let's say this is L, then L is the same as the limit as x tends to 0 as d dx of g of x on the top and d dx of p of x on the bottom. But you have to note that this means at this particular point on the function, if you wanted to say this point is this exact value, you have to say that, well, the limit is this, but it's actually incontinuous at this point. Okay? So in that case, we get g prime of x is equal to p prime of x, and that is the limit. We're still evaluating the limits. So if we apply this case, in this case, this function, then what do we get? Well, let's evaluate the derivatives of both the numerator and denominator first. So we get the derivative in terms of x of sine of x multiplied by the cosine of x is equal to cos, or the cosine, of x multiplied by the cosine of x multiplied by the derivative of the inside function using the product rule. We get cos of x plus the derivative of the second thing. That's going to become a minus because the derivative of cosine x is negative sine, so we get negative x sine x. And that's going to be all over the derivative. Well, let's get to that. D dx of x is 1. So we get the limit, we get L is equal to the limit as x tends to 0 of this stuff, cosine x multiplied by cosine x multiplied by cosine x minus x sine x, all divided by 1. Okay? So we essentially don't have a problem at this stage, but what you can see is, well, we dealt with an idea of basically having 0 over 0, but this is going to be 0 multiplied by 0. 0 multiplied by 0, is that indeterminate? No, that's just 0. Anything multiplied by 0 is 0. But let's get to that. So now let's evaluate this limit. L is going to be equal to the cosine of 0 multiplied by the cosine of 0 multiplied by the cosine of 0. A lot of cosine of zeros here. Take away 0. I was about to put an x, my bad. Of 0, sine 0. And using a different color here, we'll get here 0 multiplied by 0 is 0. Here we get 1. And here we get 1. Here is 0. So we get the cosine of 0 multiplied by 1 minus 0. So we get cosine 0 is equal to 1. So the limit of this thing, I think I put the wrong thing when setting up the equation. Yes, I was supposed to prove that it was 1, so this is the correct answer. So the proof of this limit being equal to 1 is solved.